are going to be entering differentiation. But we can't really understand the meaning of differentiation, or we can't work on differentiation without understanding what function is. Because if we're going to be differentiating, we're actually going to be differentiating functions. So we have to understand the meaning of a function. Now, class, if I write y equal to x squared, y is dependent on the variable x. If, for example, I make the variable x equal to 2, what will y become? What will be the value of y? Y will become 4. Because if I put x as 2 here, that is 2 squared. 2 squared becomes what? 4. Are we together? Now, if I put the value of x as 3 now, what will be the value of y? You see that any value I put x as, y changes. Hence, you can say y is a function of x. Function of something means y is determined by x. So y depends on x. So hence, y is a function of x. So we can say y is equal to f of x. So it's another simple way of saying y is a function of x, which is equal to x squared. So in place of this y, I can write it as f of x, which means function of x. Now let me ask you, if I write that b is equal to y plus y squared plus y, b is a function of what? B is a function of y. So I can say that b is equal to f of y, which means all the values of b are dependent on y, which is equal to y squared plus y. It doesn't matter how many y's on this side. So long as whatever is here is dependent on whatever is here. And whatever variable is here, that is the function of whatever variable is here. If we bring down this f of x now, for example, and then make, just like I said, make x equal to 2. Are we together? If we make x equal to 2, it means we are limiting the value of x to become ordinary 2. So if I put x as equal to 2, it's the same thing as saying I limit the value of x as what? As 2. So if I put the limit of x to be 2, which means limit of x as x tends to 2. That's how it's written in further maths. So limit as x tends to 2, which means you are limiting the value of x to become 2. F of x is equal to. Now, what it means is that on the other side, wherever you see x, put it as 2. So that here now becomes 2 raised to power 2. Are we there? So hence, the lim as x tends to 2 of f of x in this function becomes 4. Now, let's go straight to the next properties of function. We have about 5 properties of functions. 5, right? Now, all the properties are all based on limiting values of function. All right, so first property, property 1. Let me say e.g. Are we together? The limit as x tends to a of 5, which 5 is a constant, is equal to 5, constant itself. Are we good? Is that unclear now? Then number 2. Again, let me interpret it now, right? Are we together? They said the limit as x tends to a of a series. Here they put it as finite, which means many number of functions. Are we together? The limit as x tends to a of many number of functions added together is the same thing as taking the limit of each functions one after the other and also adding them up together. E.g., so let's give you an example. E.g., let's assume that you have f of x as eh, as 2x squared plus 3x plus 1. Do you see that? Now there are many functions there, about 3 functions. 1 function, 2 function, 3 function, though the last one is a constant. Are we together? Now, if they ask you to take the limit of the whole of this function, for example, set the limit as x tends to, what will you choose? 2. Limit as x tends to 2 of f of x is the same thing as taking the individual limits. So that means you have to take this limit plus take this limit plus take this limit. So let's take this limit. That will be limit as x tends to 2. What is there? 2x squared plus limit as x tends to 2. What is there? 3x plus limit as x tends to tends to 2, 1. Remember, limit of a constant is what? Constant itself. Don't forget that rule. So that's rule 1. Now, let us now take the limit individually. So that will be equal to limit of this one, which means limit x to be 2. So if we limit x to be 2, that will be 2 raised to power 2 into 2 raised to power 2. Abi? That means anywhere you see x, put it as 2. So 2 into 2 raised to power 2 plus this one, 3 into 2, 3 into 2, then plus the limit of this one is also 1. So limit of a constant is constant. So that will be equal to 2 to 2. Now this is 2 squared, which is 4. 4 Abi, 2 into 4 plus this is 6 plus 1. So we get 2 times 4 is 8 plus 6 plus 1. That will give us that will 15 Abi. Answer. Number 3, that's proper. The limit of the difference of two functions is equal to the what? The difference of the limit of individual functions. So what it means is that, e.g., let's have an example, right? If you have f of x as, let's say, 5x raised to power 3 plus 3x raised to power 2, sorry, minus 3x raised to power 2 minus 4. Or let's end it here. Now, you are asked to take the limit as x tends to 2, for example. So the limit as x tends to 2 of f of x, which is equal to 5x squared minus 3x squared, is same as take the limit of the two individually and still subtract. So the same thing as the limit as x tends to 2, 5x raised to power 3 minus the limit as x tends to 2, Abi, then 3x raised to power 2. So what it means is take the limit now. Anywhere you see x, put it as 2. So you have 5 into 2 raised to power 3 minus 3 into 2 raised to power 2, which is equal to 2 raised to power 2 is 8. So you have 5 into 8 minus 3 into 4. That will give us, that's equal to 40 minus 12, 28. Number 4. The limit of the product of functions is the same as the product of the limit of individual, I'm coming on, functions. Now, the limit of the product of a function of functions is the same as the product of the limit of individual functions. E.g., we have, if we have f of x to the limit of f as x tends to 2, for example, um, f of x, and the f of x is, what shall we put? 2x squared times 2x times another x, for example, right? Now let's do that. It's same thing as taking the limit individually and multiplying them together. So you have lim as x tends to 2, 2x squared times lim as x tends to 2, 2x times lim as x tends to 2x. Then you now take the limit now. So this one will be 2 into, since the x have been limited to 2, we put it as 2 squared, abi, times, this one has been limited to 2 as well, 2 into 2, then times again, only this one will be 2. Are we there? So that will be equal to 2 squared is 4. So we have 2 into 4 times 2, that's, this one is 4 times 2. So that will give us, this is 8 now, be, times 4 times 2. That will be equal to what, class? Everything will be equal to what? 64. 5. Now the fifth one is quite obvious, which is, okay, so that is that. So let's say e.g., are we there? E.g., we have, if we have the limit as x tends to 3, for example, of f of x, which is, let's say, 3x squared over 4x. Are we together? The same thing as taking individual limit, which is lim as x tends to 2, sorry, 3, abi, 3. 3x squared all over lim as x tends to 3, 4x, which is equal to, put x as 3. So you have 3 into 3 squared all over, all over 4 into 3. So that will give us, this is 9. 3 times 9 over 12. So that's what? 27 over 12. 3 can go. So you have 9 over 4. So at this point, we are done with the properties of functions. Please, I need you to subscribe.